Okay, so let me put the lights here, that way I see this a little bit better. Okay,
Yeah,
all right,
pretty much.
goal today, we're doing the third section. It's 1 day section. We're not gonna spend 2 or 3 days doing it, like we did the last section, because it's a continuation of what we just learned the last 3 days. Okay, it's about integers, which are what type of numbers?
They're the negatives.
Negatives. Any type of negative, but not decimals. They're nice, clean, whole numbers. So integers and the number line. First activity today that I'd like you to do, you get 1 minute to try this. So you need your notes out, you don't need to tear anything out, just leave it in your notes. What I'd like you to do here is to draw a number line. Simple fact. What do you remember about a number line? Label everything that you can. You have 1 minute from right now. Got it? Go. I'm going to check it here in 1 minute. So draw it in your notes. I'm walking around, I'm going to check everybody's notes just to see what you have. Everything you know about a number line, because we talked about it yesterday.
What is the only one? Integers? He said a number. It leaked in the bruise.
Okay, you got about 30 seconds left here. Try to draw as much as you can on this number line. Leave it in your notes, you don't need to tear it out or anything like that. I am going to check it. I want to see what you remember, what you know, what you can recall about it.
Okay.
10 seconds. All right, pencils down. Put them off to the side. I want to see your notes, so have that in front of you. I want to see what you have labeled. This is going to be a quick check. It's like a 2-second check. I just want to see what you have on your number line. Did you draw one?
Yeah. 5 times.
Okay.
Yeah, I thought it was gonna click like that. That would have been good.
Who turns around?
Mine didn't click so fast.
What?
Mine didn't click so fast.
My caption, someone smoked with the
I
foot.
mean, that first, he got the tackle.
Okay, everyone's got the basic idea, as long as you actually happen to draw it. So, here's the idea. If you didn't remember from yesterday, here's the concept. You better have 0 on it. 0 better be, it doesn't have to be dead center, but that is called the origin of a number line. It is the main focus. You have to draw 0 first. Going to the right, we typically have positive numbers going this way. We go to the left, we have negative numbers. Most people have that if you did it. I've seen 1 or 2 examples where they started at 0, and then they just counted up to the right. They didn't do any negatives, but you get the idea. Now, here's the idea. These numbers that you have in front of you are integers. They're the integers. That's what most people think of as a number line. It's all the integer numbers, positive, negatives. No decimals. Some people did put decimals on theirs. It's not necessary, you just need to have whole numbers. But you have to recognize that there is multiple numbers here. Now, here's the weird, goofy thing. If you go to the left and you start seeing these negative numbers, I know this seems weird, it's getting smaller. Even though you get to -3, that is a smaller number than -2. Because as you go to the left, you hit smaller numbers, no matter where you're at. That's the typical thing about a number line that people just don't think about. This is the concept we're using in all of our problems today. This visual aid. So keep that in mind where your number would sit on a number line. Okay, as we go through each problem today. Okay, now there's a couple of vocab words I want to talk about, because obviously we've been talking about verbal expressions in here. What are keywords that we would use for integers? So here's a list of things that I'd like you to have. I need to change the ratio here. Let's see.
Huh?
There we go. Okay.
You need one.
Zoom.
Okay. So think about this. These are just little options for us to get us kind of thinking about these terms, these ideas of integers and rational numbers. Or not rational, but the number lines. So Correct integer in each case. A loss of 8 yards. Which number up here out of these integers would represent a loss of 8 yards?
B.
B. -8, right? Negative means a loss. That's the concept of why we have negatives in the first place. Represents that you're in the negative, you're below 0, right? You've lost something. You've overspent something, right? Next one. Andrew gained 12 pounds for wrestling.
A.
It's a.
A, okay? For wrestling, that's probably nothing for wrestlers. They can gain or lose that in a couple days, just because of what the conditioning they have to do.
It's horrible.
Yeah, it's bad. It's bad for your body. Tate deposited $45 into his savings account. A, right? Depositing means you're adding money in. If you withdraw, that'd be a negative $45. Temperature went from 73 to 63. Yeah,
B.
-10, right? We're dealing with that this week. Every other day this week goes from 80 to 60. Today's a 60-degree day. Tomorrow's an 80-degree day. It's jumping constantly back and forth each day this week. Okay, same thing with our number line. This is something that you just don't think about. If I give you a number line, you had a bunch of blanks on it. You guys know what a number line is. You just drew it 10 seconds ago for me. What would these numbers need to be? So on letter A, what number do I need to fill in this blank?
21, -21.
How do you know?
So it's not going to 1.
Yeah, it's going up by ones, right? You're recognizing that there's a gap of ones. Number lines don't have to always jump by ones, but you recognized it. You saw that each number, bottom row, what numbers need to go in these spots?
-10
4.
and -4.
Good, because what is it jumping by?
2.
Twos. It's whatever number line you wanted. I didn't tell you to draw the same number line. You could draw any number line. Some people went up to 16s on their number line. Some people only went to 5s. It doesn't matter. I didn't see anyone jump by 2s. You could have. It's depending on what you recognize as a number line, right? But as you go to the left, these numbers are getting smaller. Next one, letter C here. What numbers need to go in these blanks?
-10
Okay,
and 5, 10.
good. Jumping by 5s. We recognize it. That's a number line. Doesn't always have to jump by 1. Bottom row,
75.
and
65.
good. Negatives. Right. Good. You're recognizing where they need to go. All right. Last ones here. What needs to go in these blanks?
-80.
And
-64.
good. And negative
0.
3 and 0. Okay. So the origin is missing on that one. Now, here's the thing. If you've recognized every example I provided to you, they've all been equally spaced. All been very clean, easy numbers to figure out. Because if they're equally spaced and you can see the spacing from one number to the next, you have to continue that spacing. I don't want to suddenly see that -40 to -20 and then suddenly goes to -10 with the same spacing. That's the thing that makes these a lot easier to recognize. They're using the same numbers every single time. They're either jumping by 2s or 10s or 5s or 20s. You're starting to recognize that concept. It's a weird thing, like, I didn't tell you the type of number line to draw, but everyone's got that image in their head. I thought these are just kind of interesting ones to kind of talk about. All right, next topic, because I think you get the number line, right? You get the idea. What we have to talk about now is an inequality symbol. Okay, inequality symbols in math are comparisons. How do we compare one number to another? Is one bigger? Is one smaller? That type of thing. You have 4 basic symbols for inequalities. They're right here. The symbols are the things that most people in math get wrong because they don't know how to read it. Reading math is actually kind of difficult when you actually step back and you take a look at it. But the first symbol, this is called the less than symbol. That's how you read it. Now, here's the thing. The less than symbol, all it is comparing 2 numbers. You put a number on the left side, you put a number on the right side. What number needs to go in each spot depending on what you're comparing, right? It could be money, it could be just integers, it could be rational numbers, it could be anything you want. But on this number, so if I'm comparing 2 different numbers here, let me get rid of that. So if I'm comparing 2 different numbers, which number needs to be smaller? The left side or the right side?
Left side.
Why the left? pointing to the right. Okay. What else gives away? Why does this number here need to be smaller than this number? What else gives it away other than it's pointing a certain direction? What's another visual aid for you? It's a hard concept to explain, right? You're thinking about it like, well, I just kind of know, right? The left side would be smaller, the right side would be greater. Here's the idea. I look at the ends. One end is larger, one end is smaller. That's literally how I compare it, right? The bigger end has a bigger number, the smaller end has a smaller number. Other than a direction that it's pointing, you can use it as a visual aid. But again, that's the less than symbol. Okay, the next symbol is a greater than symbol. Same exact concept. Even though you read it as a greater than symbol, you're just comparing two numbers. That's all you're doing. Where does the bigger number need to be, left or right? Left, right? Because on the left side, the bigger spot is on the left side, so you have to have the bigger number on that side. The smaller number goes on the right side, because that's the smaller end of that arrow. So whatever numbers you picked, if I picked 1,000, and I picked the number 10, you just have to make sure which number is bigger. That's what you're comparing. Now, what about negatives? I want two numbers that go in these spots, and they both have to be negative numbers. Can somebody give me two examples of negative numbers I can put in those two spots? Please.
-1 and -3.
Okay, -1 and -3. And you're absolutely right. That's that weird concept. -1 is technically a larger number than -3 because of where it sits on a number line. If you think about that number line we just drew a little bit ago, -1, -2, -3, these numbers are larger. As you go to the right on a number line visually, you're getting bigger numbers every time. So -1 technically is a bigger number than -3. So they're on the correct side because of the symbol I'm looking at. Does that make sense with negatives? Now, the really hard part is when you get to decimals, because most people are not comfortable with how do you compare decimals when there's multiple decimal places. But the good news is, we're not dealing with decimals today. We're dealing with integers, nice clean numbers, negative or positive. Okay, on the bottom row, which number is bigger? 3, right? So the symbol I can put is that. 3 is a bigger number. Now, the two symbols I have not talked about yet are these two down here. These are the exact same symbols as the ones above. The only difference, they put a bar underneath it. So when you actually say this out loud, it's less than or equal to. They literally mean the same thing as the ones that I just used a little bit above. So on this problem, this example down here, I could have done this. It's the same thing, less than or equal to a 3. The bottom one is greater than or equal. They're the same symbols. They literally are just comparing two numbers. If they happen to be equal, so be it. Questions on the inequality symbols? Now, again, why I brought it up. When you're talking about the number line, most people use it visually to see where your numbers are sitting. A thermometer, if you're checking your temperature, it's a number line. That's literally what it is. The mercury inside the thermometer just moves depending on the heat, because it expands and then the mercury moves to a new spot. All right, questions at all about the symbols? Okay, pretty straightforward. Now, all you have to do is tell me the symbols that go in these spots. So here's what I want. I want 4 volunteers. 4 volunteers. You can raise your hand. You can come up here. You can put whatever symbol you want up there for A, B, C, D. I'll turn off the camera so you're not on camera. Some people don't like to be that way. I'll turn off the camera. I want you to put the symbols in those correct spots. Okay? One spot. So if you're going up, grab a marker, put your symbol where you think. You have 4 options to pick from. I'll turn off the camera. I want my four volunteers. Okay, let's talk about it. First one, greater than symbol. I agree with that first one. No, now, here's the weird part that I noticed. No one did greater than or equal to. You could have, because they're the same symbols. You can put bars underneath it. But I agree with the top one. 8 is greater than 3. The bigger side's facing the 8. 14 is bigger than 6, because where it falls in the number line. 7 is greater than -2, because 7 on the number line is to the right, so that is a bigger number. And this one is probably the hardest one up there. -10 is larger than -15, because where -10 falls. -10 is to the right, -15 is to the left, so -10 is a bigger number. Okay, questions on those 4? Thank you for the volunteers for that. That takes a lot of guts to get up there. All right. Next. Okay, absolute value bars. This is something that you probably have seen in general math, 7th to 8th grade math, where you're in it, whatever you're in. Absolute value, by definition, is a distance. That's all it is. That's what that symbol means. It's a distance from 0. Your smartwatch, your Apple, your Apple Watch, whatever type of watch you have, if you're doing it like a tracker to how many steps you're taking, it's actually doing an absolute value in the background. It's taking your 2 numbers. It's taking your starting position, your finishing position, it's subtracting the distance between there, it's telling you how many steps you took. And it's doing a distance from 0. It considers this to be 0 because I stopped, and now it's figuring out how many steps I take, and it adds it to my total. When I walk backwards, it's still doing the same thing. It's still adding, it's always a positive number. So, if I tell you that these are always positive, what's the answer for this top one? If it's always positive.
4,
4,
7,
7,
0,
0, and
12.
12. It's always a positive number. That's exactly how a smartwatch keeps track of your pedometer and how many steps you've taken, or how many miles you walked. It doesn't matter if you walk forward or backwards, it's still counting steps. Because it's an absolute value, it's your distance from 0.
Wait, what if you just stand there and walk in place?
Walk in place? I don't know, because that's a thing, like, I don't know if it will actually register, because certain pedometers are different. It depends on, like the smartwatch, I think it uses GPS, tracks like where you're moving, but some pedometers just use the motion of going up and down. So like you can be on a Stairmaster, and it will count how many steps you take, even though you're not going any distance, you're just going up and down. Just to give you an idea, like when I first got an Apple Watch, the first Apple Watch, it couldn't track GPS very well. It didn't know what I was doing. It registered that when I went to the fair on the 4th of July and I got on a Ferris wheel, it marked that I went 26 miles that day. Because it didn't know any better. It knew that I went in a circle, but it thought I was running. Because the actual Ferris wheel goes slow enough that it can mimic a human, speed for running. And my heart rate was elevated, right? Because I'm scared of heights. So it literally registered that I was on a workout, and it said I ran a marathon that day, and I got a medal for it, even though I didn't, right? But nowadays, the smartwatches are way better. It can tell that I'm not moving. It can tell by like the actual arm motion that I'm taking, right? It's one of those things like modern technology, even though, your smartwatches or phones do this, it still uses this concept. This is literally the math in the background of that. It is actually using that symbol to calculate math. Okay, questions with the absolute value bar. Okay, on these. Now here's the weird thing. We're going back to the same thing we did earlier. Greater than, less than symbols, or equal to, it doesn't really matter, you can put them. Now I'm going to throw absolute values in there. So, bigger, smaller, what do we got? Which one's a bigger number on letter A?
Oh, 6.
6, right? Because this number is 3, that's 6. What about this one over here?
4.
Yeah, 4. This number is technically a bigger number. Even though I know it says -4, you're doing the absolute value of it. Okay, questions at all about all the stuff we're doing? I think you get the idea, the concepts that we're in. All right. Homework today. We have that worksheet 0.2, one I handed you yesterday. It's due tomorrow. I know some of you already turned it in. That's great. If you haven't, that's something you need to finish. Your class line. We have a new handout today. It's comparing numbers on number line. Which number is bigger? I think you guys get the idea. We probably don't need to spend multiple days talking about it. So I'm going to hand out this worksheet. You can hand it in with the other one, or you can hand it in separately, but they're both due tomorrow.
It makes us do so much work.
Me?
No, not you.
I was like, I don't think I'm doing too much.
Mr.
Yeah. You should see his semester tests.
Yeah, you have.
They're huge. Me. His semester tests are incredible.
When we walk in there,
These
Oh, yeah.
are horrible.
Yeah, they're massive. Mine are like 15 questions. This is like 200.
200?
Okay, this is due tomorrow. I think you guys get the idea. You can compare numbers. Put your name on it, first and last name. Make sure you're doing that. I better check the worksheet. Yep, everyone's got it. Again, if you want to make fixes on any of the worksheets I handed back to you yesterday, make fixes, turn it in. You got a week to do that.